Howdy again, everybody, and welcome to another review session for Calculus 3208. This time we're looking at evaluating inverse trig expressions as we prepare for taking derivatives of inverse trig functions, which is our next big topic we're easing our way up to here very slowly. So this session and one more before we get into that. So let's start with this stuff. It says evaluating inverse trig expressions, so what we have to deal with is we're going to use principal values to evaluate them to make sure we don't make any issues in terms of not being a function. And then we're going to talk about ways to evaluate composite expressions of a trig function and its own inverse. So we can make composite functions of two different trig functions. One is an inverse and one is not, where they aren't the same, like they're not both cosine or both sine or whatever. But that's our next session. So for today, we're just looking at when they're the same thing, because there's a couple of tricky issues we have to be careful about here. This is pretty subtle stuff. Okay, so let's get started. When we evaluate a trig expression, an inverse trig expression, excuse me, we take something like the inverse sine of 1/2, okay? So it's always a question we ask ourselves. What angle or angles would give me a value of 1/2 for a sine ratio? And that's pretty straightforward. We all know how to do that. It's like solving the trig equation, sine of x equals 1/2, and then what would x have to be? Same kind of thing. So if I do that, I realize that I could have pi over 6. If I had sine of pi over 6, I'd get 1/2. Or sine of 5 pi over 6 would also give me 1/2, plus any multiple of 2 pi, as long as it's an integer multiple of that. And we'd have an okay solution. But we have to keep in mind that we're dealing with restricted ranges when we're talking about inverse trig functions. And the thing that we restrict is that we say that the values we get from an inverse sine are not allowed to be any less than negative pi over 2, and they can't be any greater than positive pi over 2. We call those the principal values if you watched our last session. So let me just give you a quick diagram. Whoa, this is a bad diagram. But if I think of this as a unit circle, basically one way to think about it is if I'm evaluating an inverse sine using principal value stuff, so basically pretty much any time I'm using it, then I've got to be between negative pi over 2 and pi over 2. So I can go in this direction as far as the y-axis on a unit circle, or in this direction as far as the y-axis on the unit circle. Any further than that, and I'm going to violate the rules of what it means to evaluate an inverse sine and stay within its range. Okay, so basically, the only possible answer out of this whole group that would fit inside that is pi over 6. So let's take a dip into a little bit of a more confusing thing here now. So we're going to look at what happens when I take a function applied to its inverse of x. Well, or if we take the inverse applied to the original function in the other order. Typically, mathematically speaking, as long as they're both what we call one-to-one functions, which is not what we're dealing with here, but whichever way I do that, we almost always say that we should get an answer of x. Okay? Now, that's not really always the case when it comes to these inverse trig things, because they aren't one-to-one. We had to restrict their domains. So let me show you what I mean. If I go in the order where the inverse is the inside function and the original is the outside function, that's not an issue. So watch what happens. I evaluate the inside bit first. So inverse sine of root 3 over 2. So where is the sine equal to root 3 over 2? Well, the only place that's going to fit within my principal value range is going to be at pi over 3. So basically, this is just the sine of pi over 3. And as we just said, the sine of pi over 3 is root 3 over 2. So that seems to make sense, I guess. Okay, so we didn't get anywhere with that one. Let's take a look, however, let's take a look at the next one, in the same order, and we should get the same kind of thing happening. So let's take cosine of, now, inverse cosine of negative root 2 over 2. So remember, principal value only, and for cosine we're between 0 and pi. So what value of an angle between 0 and pi would make cosine equal to negative root 2 over 2? And the only possible answer there is 3 pi divided by 4. And we know that cosine of 3 pi over 4 is actually equal to negative root 2 over 2. So that makes sense. The function of its inverse of any x is just equal to x. Like we said, same thing here. The function of its inverse of an x should be equal to x. Okay, this is where it all starts to break down. When we go in the other order, putting the inverse on the outside and the function itself on the inside, Sometimes it works and sometimes it doesn't. So let's take a look. Now I want to take the inverse sine of pi over 3. Okay, well we just said that sine of pi over 3 was root 3 over 2. So if I want to take inverse sine or arc sine of root 3 over 2, well, as we just saw a minute ago, that shouldn't be an issue. That's pi over 3. So everything seems to hold up just fine. But look at this next one. I got to take the inverse cosine of the cosine of 5 pi over 4. And notice that the 5 pi over 4 that I'm starting with here, 5 pi over 4 is not, it doesn't belong to the interval we have for the principal value of cosine that goes from 0 up to pi. That doesn't mean we can't do this though, because we can still evaluate the cosine of it. That's not a problem. Okay, so cosine of 5 pi over 4 is, okay, that's negative root 2 over 2. So I've got inverse cosine of minus root 2 over 2. But if I take the inverse cosine of minus root 2 over 2, I'm only allowed to be between 0 and pi, and there is a value for that in there. It's at 3 pi over 4. So in this case, when I have the inverse on the outside and the original function on the inside, sometimes it works out hunky-dory with what we normally think of as being inverses, but sometimes, doesn't work out so great. So here's a trick. If you don't want to goof it up, just evaluate the inside first and the outside after, and that typically takes care of the issue. All right, let's move along. Here are some examples of evaluating inverse trig functions. And I just drew a little unit circle here so you wouldn't have to see my hand scratch trying to do it by hand. And for each one of these, as I do that, what I'm going to do is I'm going to just trace around the circle to where my principal value range is going to be. So for tan, we should remember that for tangent, the principal values of tan are always between negative pi over 2 and positive pi over 2. So this side of the unit circle is where I have to be for tan. And if that's the case, I have to take the shortest angle that gets me there. And if I'm going to find out where tangent is equal to 1, well, there's a couple of places actually where tangent is equal to 1, and you should remember from your vast studies of trigonometry and other courses that they're going to be on opposite sides of the unit circle. So one of the possible places where tan is equal to 1 would be up here at pi on 4. And we could also have it way down here in the nether regions, and that one is at 5 pi over 4. And both of those angles would give me values for tangent that are equal to 1, but this one is outside of my principal value range, so the inverse tan of 1 is only pi over 4. There's only one possible solution to that. Okay? Let's erase that out and try another one. Okay, so the next one here says, how do I evaluate the inverse cosine of negative root 3 over 2? So for cosine, I'm going to grab its principal value range, and cosine starts at 0 and can go in one direction only, all the way as far as pi. So where is cosine equal to negative root 3 over 2? Well, there's a couple of spots on the unit circle. One of them's over about here, and one of them is down about here. So we've got a pack band going on here, even the right colors, look at that. So let's think about what those two angles would be. The one that we're going to be allowed to keep, of course, would be 5 pi over 6. So that one's A-okay. But this one down here at 7 pi over 6, that's outside the principal range, so we've got to eat that one and just keep 5 pi over 6. Listen, if you want me to eat 7/6 of a pi anytime, I am game. Okay, so let's clear this out again and start the next one. So we'll delete that. And now we have the inverse sine of negative root 2 over 2. All right, so let's remember our principal range for sine, which is the only one we haven't discussed yet, but it's the same as it was for tan. It's negative pi over 2 to positive pi over 2. So where is sine going to be equal to negative root 2 over 2? Down here and down here. Okay, so those are our two magic places, and we're only allowed to keep the one that fits, and the one that fits is this angle right here. Now, I can't go for this one around in this direction and call that my angle. I'm not allowed to do that because that would take me outside of my principal value range. So I've got to get rid of that stuff. Maybe you go the other way. Okay, we'll get rid of that stuff. So what I have to do is take the direct route there. So the only answer I'm allowed to have for this is if I go in the negative direction to get to that terminal arm. So that's going to be an angle of negative pi divided by 4. Okay? So that's straightforward how we evaluate those. Excuse me. So now what we're going to do is we're going to talk about these composite things that we look at a couple of examples of those, the ones we talked about earlier. Now, we're doing the tan for the first one. Now, if I take the inverse first and then the tangent, if you remember from before, that typically does not create any issues at all, okay? Just try to remember that as long as the inverse is on the inside, makes it a lot easier. I don't even care that that's not a special angle or a special number, any kind of thing at all. I know that if I'm dealing with tangent, that's a-okay. Those two just cancel each other out. However, for cosine, if I've got the cosine inside and the inverse outside, I can't do it that way. So I have to start by evaluating cosine of 11 pi over 4 and then take its inverse. And basically this has the effect of just taking the 11 pi over 4. So let's see if we can plot 11 pi over 4 on a unit circle. So 11 pi over 4. So 8 pi over 4 would be all the way around the circle once, and then I've got to go another 3 pi over 4. So that would put me in a position right over here. Okay, so what this does is it has the effect of looking for a coterminal angle with the 11 pi over 4 that fits inside my principal range for cosine, which is just 0 to pi. So that angle right there has got to be 3 pi over 4. So this is 3 pi over 4, because cosine of 11 pi over 4 would give us an angle of, or an answer of rather, a ratio of negative root 2 over 2, and the inverse cosine of that is just 3 pi over 4. Okay, for the next one, we got to be careful with this one as well. So we'll start with sine of negative 12 pi. All right, so how are we going to attack negative 12 pi? Well, 12 is an even number, so this is a multiple of 2 pi. And since we're dealing with a multiple of 2 pi, we're just going in the negative direction. So round and round she goes, and where she stops, I think I know, is it's going to be right over here at 0 or 2 pi in the same place. So within the principal range for sine, what's the angle that I get over here that works for my inverse? The only angle I can have there is 0. So this gives me an angle of 0 radian. Okay? So that's lots of fun. You could evaluate this and find out that sine of negative pi over 12 is 0. So I have inverse sine of 0 and go through all the steps. But once you realize what it does, applying the inverse to the original, all it does is it takes whatever angle is in here and it gives you the coterminal angle within the principal value range. Alrighty. So we move along now. Here's the or turn question. Just some of those same types of things for you to try. Hope you enjoy them, and I hope you get them right. So I'm going to flip now right over to the solutions. If you want to pause the video, go for it. So here are the solutions for those, worked out in their gory detail, which is not a whole lot because there isn't much to them. But hopefully you're getting this stuff right, and if you're not, you're figuring out why. And let's take a look at some of the key highlights of things that we saw. So the key highlights are we evaluate inverse trig relations by thinking of the angle that produces the given ratio, same as before. And it says this is all the same stuff as last time. Since there are multiple answers, we have to restrict our domains. And the one thing we're going to have to be really careful about is that I screwed this up over here, and it's supposed to say strictly less than and strictly greater than. So that's better now. All right. And it says, when evaluating expressions composed of a trig function and its inverse, it's best to work from the inside out to avoid errors involving principal values. If, however, the inverse is on the inside, you can skip right to canceling out those two functions and taking the argument as your final answer. All right, so hope that's helpful. And really what we're doing here, remember, is we're setting ourselves up for the calculus bit that comes with inverse trig. So we're soon going to be taking derivatives of those. All coming soon, I promise. Congratulations on learning something, and I hope your study is going well.